Okay, going through the quiz. When solving the problem below, what's the first thing you do here? Distribute. Distribute. You shouldn't try and combine like terms or anything outside those parentheses until the parentheses are gone, because parentheses, PEMDAS, that's the first order of operation. So we've got to distribute. Okay, how could we simplify this expression? What do we know is in front of the parenthesis? -1. So it's not 5 times, it's 5 minus that whole thing. And so I've got to make sure and distribute the -1 to both terms. So it's 5 minus 2x plus 3. And 5 plus 3 is 8. So 8 minus 2x. Okay? Which is the top one on mine. How many videos? 3. As described in the textbook, when you solve a problem with decimals, you approach it like any other problem. True. And then the real-world problem presented in the beginning of the section was about cell phones. Okay, so I just want to show you, because there's CK12 today, in the first period, there were several questions, and I'm trying to think if I can of it's probably not going to come out with an integer like CK12 will, but okay, you have a choice now that we've kind of learned that least common denominator method. You have a choice when we do problems like this of trying to get rid of fractions right away. Hello? Yeah.
You have crystal file?
Yeah.
Can you send it to my office, please?
Sure.
Thank you.
Personally, I like using the least common denominator method when I have multiple fractions, like every term's a fraction. Here, 8 and 7 are not. They're integers, right? So I'm probably not going to use the least common denominator method. I'm just going to go ahead and handle the problem as it stands. If 8 was 2/3 and 7 was another fraction, the first thing I would probably do is figure out the least common denominator and multiply the whole thing through and get rid of all my fractions. But for now, I think I can handle this one. Okay? So I'm going to go ahead and do what first? That should be an X, sorry.
Okay, never mind.
Sorry.
Now you get least common denominator.
Yeah. Okay, and so now it's just a matter of adding these two fractions, right? A trick to add fractions. This was a John Baylor trick. Maybe I've shown it to you already. Figure out what the denominator should be. What is it? 20. And then he calls it the crisscross method. Okay, I multiply 2 times 4. And I multiply 5 times 3, and that's my numerator. As long as you've got the sign in the middle. If it was a negative, I need this to be negative. Yeah. Yeah, okay. All right. Okay, so that's 23/20ths, right?
That's improper.
You're right. Okay, now how do I solve this?
What times 23? So you divide -1 by 23/20.
Okay, and so here's the mantra that I, again, want everybody to have in their head. When you divide by a fraction, you multiply by reciprocal. So don't ever divide this by a fraction.
You will. What you do is you go -1 in parentheses times in parentheses 20 divided by 23.
Because the reciprocal of a fraction makes this 1, which is my goal, trying to get x by itself, right? So don't divide it by 23 over 20. Multiply by its inverse. Multiply by the reciprocal. Just flip it and multiply. Okay? So x is equal to a messy fraction. CK12, most of your answers should be integers. I just came up with a problem and, of course, didn't work. But questions you had? There's several web work problems. Like that. So how do you solve that? Multiply by the reciprocal and simplify.
I think there was one of them that you don't even need, like it's so simple, one step that you don't even have to show your work.
Yeah, just add a number or something.
Yeah, just like off the top.
Okay.
you can do it.
Questions on dealing with fractions then in problems? Again, my hint to you, if all of your numbers are fractions, which they aren't in this case, but if they all are, then use the least common denominator method. If they aren't, then just simplify. And then remember, this method is kind of cool for adding and subtracting fractions. The key is to find your least common denominator, but then you can crisscross and solve, and it's a nice method. Okay? I am recording this, so I'll put this up in case you get stuck tonight trying to do some problems on CK12, so you've got access to it. I am.
Can I say something? For future Colton.
To future Colton.
Colton wants to say something.
Hey, future Colton, do your homework.
Any other questions?